Hello, welcome to Relative Frequency. This is your starter. So it's all about the equivalence of fractions, decimals and percentages, which is something we've looked at in recent weeks, and also something that you'll need for this session today. So if you'd like to have a go at bronze, silver or gold, if you pause the video now. Here's some answers for bronze, answers for silver, and answers for gold. So if you've got all those right, well done. If not, remember it's just a learning opportunity, a chance for you to improve. If you're not sure, why don't you email your teacher and ask. So now we're coming on to the main part of the lesson. Previously, we've looked at probabilities in terms of a theoretical probability, where you've got something happening like tossing a coin, where there are only two options you can get. So the chances of getting a head is a half, and the chances of getting a tail is also a half. What we find though is if you actually do toss a coin 60 times, the chance of getting exactly 30 heads and 30 tails is not actually probably going to happen. So here's an example of throwing 60 times. We've got 27 heads and 33 tails. So from that we can say for this experiment, what's the probability it will land heads up? So it landed heads up 27 times out of the 60. So it's 27 60ths. And this is what we got from an experiment. So we call this the relative frequency. We know that the probability is a half, the theoretical probability, but this is an experimental result, so we call it a relative frequency. Now this is useful sometimes when things aren't so clear-cut. So for example, a drawing pin. If you drop a drawing pin, it can land pointing up or pointing downwards, but it's not equally likely like the coin. So to find out the probability, we need to do an experiment to actually work out the relative frequency. So here, someone's done an experiment. They've dropped a drawing pin. It's landed point up 15 times and point down 5 times. And from this, we can work out the probability it will land point up. So that's 15 out of the 20 times. So you have to add up all the things. So it's 20 times they did it, 15 and 5. So it's 15 out of 20, which isn't an option, because the probability 15 20ths has been simplified to 3/4. Here's another experiment. It's landed point up 35 times and point down 15 times. So the probability it'll land point up is 35 out of 50. And that's the relative frequency. It's the probability we've got from an experiment. So these are the two experiments we've got. In the first one, the probability of landing point up was 3/4. And in the second one, the probability of landing point up was 35 50ths. And we can compare these, but that's where the starter comes from. So actually, I personally think it easier if we think about percentages. So 3/4 is 75%, 35 50ths is 70 hundredths, 70%. We could think of it as in decimals, we could think of it in fractions, but I've gone for percentages here. So in one experiment, the probability of landing point up was 75%. In the other one, it was 70%. So which is right? Which is right? Well, the only way you're going to find out which is right is to do it an infinite number of times. And you can't do that. But the more times you do it, the more accurate it is. So the chances are that it's closer to 70% than it is to 75%, because in the second experiment, we've done it more times. And that's something we'll look at more later, but it's an important point to remember. So here are the results for a survey of cars passing a school. So we've got 4 different colours, well, red, black, silver, and not red, black, and silver. From that, we can work out the probability of the next car passing the school being silver. So there were 15 silver cars out of a total of 15, 25, 30. 15 out of 30, which isn't an option because it's been simplified. 15/30 is a half. Okay, what's the probability of the next car passing the school being black? Well, that's 10 out of 30, which is an option, so it must be D. Again, if you can simplify it, do simplify it. Molly asked for the number of people in age and recorded it in a table. So what is the experimental probability, relative frequency? The next person Molly asks is aged 21 to 40. So if we look on our little table, she's got 24 people that are 21 to 40. And then we need to add those up to find out that's 24 out of, don't forget to include the 24. So 24 adds up to 80, so it should be 24 out of 80. Again, if you wrote 24 out of 80, we thought that it's correct, but it's more proper to simplify it. What's the experimental probability? Next person Molly asks is aged over 40. So 40 to 60, that's 18. So 18 out of 80, that's B. So one of the important things to do when you're particularly asking statistics questions like this is to make sure that you've fully read and fully understood what they are actually asking. So over 40 is 41 to 60 and more than 60. So you've got the 18 and the 23 together to make the 41. So always be careful to read the question. Okay, an ice cream shop recorded the number of customers purchasing ice creams of each of the 4 flavors available. What is the experimental probability that the next customer will purchase a mint ice cream? So mint is 11, and altogether I've got 30, 40, 50. So it's 11 out of 50. That looks like C to me. Yay. What's the experimental probability next customer will purchase a vanilla or a chocolate ice cream? So vanilla and chocolate, there's 30 out of the 50. So that looks like D to me. Again, if you thought 3/5, you're better than the answer because you've simplified. Okay, cars passing a school. Okay, what's the probability of the next car passing the school being red or other? So we've got 3 red cars, 2 other cars, so that's 5 altogether. So that's 5 out of 1/6, 5 out of 30. Again, simplifying is good.